We have locked the moon. There's a far side of the moon, there's a near side of the moon.
NASA astrophysicists have finally cracked the puzzle of the moon's contrasting faces, but a new lunar anomaly poses a mysterious threat to Earth. What secrets does our closest celestial neighbor still hide, and how could they reshape our understanding of the cosmos? Stay tuned as we explore more about the moon's mysteries. After over half a century since our last moon mission, NASA's astrophysicists now claim to have solved the mystery of the moon's two distinct faces, the side we see and the hidden one. Additionally, an emerging anomaly on the moon has NASA's attention, raising concerns for Earth's safety. Even though the moon is our closest celestial neighbor, it remains full of secrets. Despite our fascination with it for millennia, the Soviet Luna 3 probe's discovery of the hidden face of the moon 6 decades ago changed our perspective forever. In ancient Eastern traditions, the moon is associated with a jade rabbit crafting elixirs, while Western folklore features a man living on the moon. Yet there's another aspect, the moon's far side, which has remained hidden from Earth until 1959. What Luna 3 revealed astonished scientists: a vastly different lunar landscape with countless craters and towering mountains. The reasons for these differences remain a compelling lunar mystery. The far side's unique silence, shielded from Earth's radio waves, has sparked speculation about extraterrestrial bases or ancient artifacts hidden from our view. The question lingers: why are the moon's two sides so dissimilar? The moon's surface patterns, called lunar mare, are ancient lava flows. But why doesn't the far side of the moon have them? Recent research suggests a colossal impact on the moon's South Pole Aitken Spa Basin created a heat plume. This plume transported chemicals to the near side, resulting in the mare's patterns. The far side, mysteriously spared, has a different appearance. During the Apollo 11 mission, as Buzz Aldrin and Neil Armstrong descended to the lunar surface, they encountered deep craters, massive boulders, and fine moon dust. Their lunar module began sinking into the dusty surface, like quicksand, causing panic. These experiences reveal the moon's intriguing history, where even its most puzzling aspects have scientific explanations. The Apollo 11 mission, while not exclusively focused on lunar research, laid the groundwork for deeper cosmic exploration. With over 2,000 moon rocks collected by courageous Apollo astronauts, insights into the moon's age, composition, and origin were gained. However, as the last human footprint graced the lunar surface in 1972, and the final Soviet lander bid its farewell, numerous lunar mysteries persisted. Decades passed, and despite Apollo's groundbreaking discoveries, intriguing questions about the moon remained, urging us to delve further. In 1993, a Japanese robot touched the moon, but it wasn't until the late 2000s that a renewed interest in lunar exploration emerged. Led by NASA, China, India, and Japan, 14 missions from these space leaders successfully reached the moon, with China achieving a historic feat by sending a rover to the elusive far side. NASA's impending mission to the moon's South Pole has heightened excitement among lunar enthusiasts. This surge in lunar exploration offers a wealth of opportunities for planetary scientists eager to decipher the moon's mysteries. One burning question plaguing scientists is why moon rocks are not as old as the moon itself. The moon, at 4.5 billion years, is only 60 million years younger than the solar system. During the chaotic early solar system, known as planetary accretion, solid objects collided and merged, giving rise to larger celestial bodies, including the moon. However, the analysis of Apollo moon rocks revealed a puzzling gap. Most were around 3.9 billion years old due to impact events, with almost none dating back to the moon's initial 600 million years. This absence of rocks from the period of intense planetary accretion raises questions about why these early rocks are scarce and what caused this lunar apocalypse around 3.9 billion years ago. This lunar enigma is just one of many that scientists are eager to unravel. Scientists propose that during a chaotic era, outer planets, once close to the sun, drifted outward, bombarding the moon with large pebbles. However, an opposing view suggests no such deluge, contending that Apollo moon rocks, particularly those from Imbrium, Serenitatis, and Nectaris craters, have missiled us. New data suggests these rocks merely represent remnants from the 3.9 billion-year-old Imbrium impact. So, which theory is correct, and how can empirical data clarify this lunar mystery? Exploring the moon's uncharted regions, such as its remote side and the shadowy South Pole, could resolve the lunar cataclysm debate. Untouched samples from these areas may hold secrets predating 3.9 billion years, challenging our understanding of early solar system events. Yet, the moon's mysteries go beyond its cataclysmic past. Scientists have long puzzled over the source of lunar water. In 2009, a remarkable discovery in moon rock samples hinted at the presence of water since the moon's formation. This revelation raises exciting possibilities about the moon's history and its role in our understanding of celestial bodies. The discovery of lunar water has ignited a new era of lunar research. Data from India's Chandrayaan-1 mission confirmed the existence of water ice, primarily near the lunar South Pole, in permanently shadowed craters at frigid temperatures of -250 degrees Fahrenheit. But the source of this water remains a perplexing question. Three compelling theories emerge. The first suggests that water ice arrived from outer space, carried by asteroids and comets that impacted the moon. The water then melted and migrated to the poles. Another theory involves the moon's surface temperature fluctuations, with solar wind-charged hydrogen meeting moon dust oxygen to release water vapor. The most enchanting theory proposes that water was integral to the moon's formation, with volcanic activity bringing it to the surface. Some scientists even speculate that all three processes may have contributed simultaneously, raising the question of which produced the most water. However, concrete evidence remains elusive. In 2009, NASA's Lunar Crater Observation Satellite found water and comet-like components, suggesting asteroid delivery. To unravel this enigma, researchers believe that collecting and analyzing lunar samples, whether by robot or human, is crucial. Deep analysis of isotopic composition may reveal whether lunar water's origin traces back to comets, asteroids, or solar wind, bringing us closer to understanding the moon's watery mysteries. The enigma surrounding the concentration of lunar water at the poles remains unresolved. Even if we uncover the water's origin on the moon, another question arises. Does the water vaporized from comet and asteroid impacts disperse across the lunar surface or remain trapped in the regolith? The lunar science community is divided on this issue, necessitating further rigorous testing. The moon, in its ancient, unaltered state, offers a potential glimpse into the early years of our solar system. By studying its primordial craters, scientists like Prabal Saxena from NASA's Goddard Flight Center believe we can unravel mysteries of the solar system's birth. Some theories suggest the moon was bombarded by asteroids nearly 4 billion years ago. If confirmed, these samples could unveil the secrets of the solar system's origins, potentially reshaping our cosmic understanding. The moon's hidden depths hold the potential to revolutionize our comprehension of the cosmos, offering insight into a time when Earth faced constant bombardment and the outer planets were much closer to the Sun, potentially altering the course of life's existence on our planet. As a silent guardian of the Sun's early secrets, the moon's recent studies, led by Saxena, highlight its role in unraveling the solar system's history. In the Sun's early billion years, it rotated 50% slower than usual, linked to the moon's unique low salt and potassium composition. Researchers, led by Prabal Saxena, created models showing how solar activity affected lunar mineral deposition. They found the Sun's slow rotation influenced lunar potassium and sodium levels. This discovery also sheds light on Venus's water loss, Mars's vanishing atmosphere, and Earth's atmospheric development. Despite our lunar knowledge, mysteries persist. A recent discovery beneath the moon's South Pole, hidden behind the massive South Pole Lake and Spa Basin, raises questions. An immense object resides there, affecting the moon's gravity. Speculations range from ancient lunar impact debris to heavy metal. Its immobility, despite lunar heat, baffles scientists. Weighing 2.4 quadrillion tons, it emits unusual energy, defying known materials. Researchers worldwide collaborate to unveil its secrets, yet many questions remain buried beneath the moon's surface. What other celestial secrets await discovery beneath its ancient surface? Feel free to express your thoughts and viewpoints. And be sure to join the Revel Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit. It's just the beginning. Keep looking up.